Welcome back to Cosmos in a Pod Space and Astronomy series.
Episode 10.
Get ready, because today we're taking a deep dive.
Into the fascinating world of galaxies.
I'm excited for this one.
Oh, me too, me too.
All right, so to start us off, can you set the scene, like way back, just moments after the Big Bang? What was the universe like back then?
Okay, so picture this. It's hot.
Okay.
A dense sea of mostly hydrogen and helium gas.
I'm picturing it.
It's the very beginning, and this is where it gets really interesting. It wasn't perfectly uniform. There were these tiny fluctuations in density, like ripples from the Big Bang itself.
Ripples.
Ripples. And those ripples, unbelievably, became the seeds of
The
galaxies.
seeds of galaxies.
Yeah.
How did something so small create something so vast?
It's all thanks to gravity.
Okay.
Over millions of years, these denser regions, with the help of dark matter's pull, started drawing in more and more gas. Think of it as cosmic dust bunnies gathering under the bed, except on a much grander scale. And eventually, they grew into massive structures called dark matter halos.
So dark matter halos acted as a kind of scaffolding
Exactly.
upon which galaxies were built.
Precisely. They provided the framework for gas to clump together and become so dense that it eventually collapsed under its own gravity. And from that collapse, the first stars were born.
The first stars, what were they like?
These first stars, called population 3 stars, were true titans, hundreds of times more massive than our sun, but their reign was short-lived.
Oh, what happened to them? Did they just fade away?
No, they went out with a bang, literally. They exploded as supernovae, seeding the surrounding space with heavier elements like carbon and oxygen. These elements, forged in the hearts of dying stars, became the building blocks for future generations of stars.
Oh, wow.
And eventually, life itself.
Wow, so the death of those first stars paved the way for,
Oh,
us.
absolutely. Those supernovae enriched the cosmic soup, allowing for the formation of more complex structures, including the first galaxies, called protogalaxies.
Protogalaxies. So how did we go from those early protogalaxies to the majestic spiral and elliptical galaxies we see today?
So the early universe was a bit like a cosmic mosh pit. These protogalaxies were constantly colliding and merging. This process is called hierarchical merging. Smaller galaxies were drawn together by gravity, creating larger, more complex galaxies over billions of years. And you know what? This process is still happening. It's one of the key forces shaping the galactic landscape we observe.
So even galaxies have a dramatic and chaotic past.
They certainly do. And speaking of drama, let's dive into the different types of galaxies we see scattered across the universe.
Okay, I'm all ears.
We can broadly classify them into three main types: elliptical, spiral, and irregular.
Okay.
Each type has its own unique characteristics and tells us a story about its formation history.
All right, let's start with elliptical galaxies. What are they like?
Imagine a smooth, almost featureless oval of stars. That's an elliptical galaxy in a nutshell. They come in a range of shapes, from nearly spherical to quite elongated. Elliptical galaxies are thought to form mainly through the mergers of smaller galaxies. And because they've already used up most of their gas in previous bursts of star formation, they're mostly composed of older stars.
So they're like the seasoned veterans of the universe.
That's a great way to put it. They've lived through the wild times and now reside in a more settled phase of their existence, giving off a reddish hue due to the abundance of those older stars.
Okay, now spiral galaxies. I know our own Milky Way is a spiral, right?
That's right. The Milky Way is a perfect example of a spiral galaxy, with its flat, disc-like structure and those beautiful spiral arms winding outward from the central bulge.
Yeah.
It's like a cosmic pinwheel, constantly spinning and evolving.
Those spiral arms are where the action is, right?
Exactly. The spiral arms are hotbeds of star formation, where vast clouds of gas and dust collapse under gravity, igniting the birth of new stars. They're the vibrant nurseries of galaxies.
It must be an incredible sight to witness those star nurseries in action.
It is breathtaking. We can see star-forming regions in nearby galaxies with our telescopes, and they are truly awe-inspiring.
So we've covered the stately elliptical galaxies and the dynamic spiral galaxies. What about the irregular ones? What sets them apart?
Irregular galaxies are the rebels of the galaxy world. They defy the neat classifications of spirals and ellipticals with their chaotic, jumbled appearance.
They just do their own thing.
They do their own thing. They tend to be smaller and more active in star formation, often exhibiting bursts of star birth triggered by interactions with other galaxies.
Oh, galactic encounters can really mess with the galaxy structure.
They can. Think of a cosmic fender bender, a near miss, or a sideswipe, These encounters can warp and distort the shape of a galaxy, leaving it with a unique and irregular form.
This makes me realize that even though we classify galaxies into these three main types, there's still so much diversity out there.
You're absolutely right. The universe is an incredible tapestry of galaxies, each with its own unique history, characteristics, and evolutionary path. It's like a cosmic zoo of galaxies out there.
Now, we've talked a lot about the visible components of galaxies, but what about the unseen force shaping them?
You're talking about dark matter, right?
Exactly. We can't see it, but it seems to be a major player in the universe's structure, especially when it comes to galaxies.
You're spot on. Dark matter, despite being invisible, exerts a powerful gravitational influence. It acts like an invisible hand, shaping galaxies and holding them together.
But how do we even know it exists if we can't see it?
We know it's there because of its gravitational effects. One compelling piece of evidence comes from observing the rotation of galaxies. Stars and galaxies orbit much faster than they should, based on the visible matter alone. This tells us that there must be some unseen mass providing the extra gravitational pull. That's dark matter.
So it's like an invisible glue holding these massive structures together.
That's a great analogy. Dark matter creates a halo around each galaxy, extending far beyond the visible stars and gas. This halo provides the gravitational scaffolding that allows galaxies to maintain their structure and prevents them from flying apart.
That's mind-blowing. We've talked about galaxy formation, the different types of galaxies, and the role of dark matter. But what happens when galaxies get a little too close for comfort?
Now that's where things get truly spectacular. Galaxies aren't static objects. They interact and collide with each other, performing a cosmic dance across vast stretches of time and space.
Galactic collisions. That sounds intense. What happens when two galaxies collide?
It's less of a head-on collision and more of a graceful, slow-motion interaction. Stars rarely collide directly because the distances between them are vast, even within a galaxy. Instead, the gravitational forces between the galaxies distort their shapes, pulling out long streamers of stars and gas.
Oh, wow.
Triggering intense bursts of star formation.
So galactic collisions can actually lead to the birth of new stars.
Absolutely. The compression of gas clouds during these encounters can spark star formation on a grand scale, leading to a spectacular cosmic fireworks show.
Are there any famous examples of galactic collisions we can look at?
One of the most stunning examples is the antenna galaxies. This pair of interacting galaxies is caught in a spectacular collision, showcasing the dynamic and ever-changing nature of the universe.
I've seen pictures of the antenna galaxies, and they are breathtaking.
They are. The images show long, arcing tails of stars and gas being pulled out as these galaxies waltz around each other. It's a glimpse into the sheer power and beauty of gravity at work.
This makes me wonder about the fate of our own galaxy, the Milky Way. Are we on a collision course with any other galaxy?
Well, here's a thought-provoking fact. The Milky Way is on a collision course with our nearest galactic neighbor, the Andromeda Galaxy.
Wait, seriously, our galaxy is going to collide with another galaxy?
It's true, but don't worry, it's not happening for another few billion years.
Phew, that's a relief. But what will happen when the collision does occur?
It will be a monumental event. The two galaxies will merge, their stars and gas swirling together in a cosmic ballet, eventually forming a new, larger elliptical galaxy.
So, in a sense, galactic collisions are part of a grand cosmic cycle of creation and destruction. It's fascinating to think about the vastness of the universe and the incredible processes that shape it over billions of years.
It truly is humbling, and we've only scratched the surface of what there is to learn about galaxies.
Well, before we get too lost in the cosmic vastness, let's take a moment to appreciate the incredible diversity of galaxies that exist in the universe. We've talked about the main types, but I imagine there's a whole spectrum of shapes, sizes, and characteristics out there, right?
We're absolutely right. It's like a cosmic art gallery showcasing an astonishing array of galaxies. We have dwarf galaxies, which are small and faint, containing just a few million stars. And then we have giant elliptical galaxies, behemoths that harbor trillions of stars.
So galaxies come in all shapes and sizes, just like, well, you know.
Exactly. And their diversity doesn't stop there. Some galaxies are actively forming stars, ablaze with the brilliant glow of newborn stars. Others are more quiescent, their star formation having slowed or ceased altogether.
It's as though each galaxy has its own personality and story to tell.
I love that analogy. It's so true. Each galaxy is a unique entity shaped by its history and environment. And by studying this diversity, we can gain a deeper understanding of the processes that govern galaxy formation and evolution.
This makes me think about the role of supermassive black holes. I know they lurk at the centers of most galaxies, including our own Milky Way.
Yes, supermassive black holes are fascinating objects. They have masses millions or even billions of times greater than our sun, and they exert a powerful influence on their host galaxies.
How do these supermassive black holes affect the galaxies they reside in?
Their immense gravity can influence the orbits of stars and gas clouds in the galactic core. They can also drive powerful outflows of energy, which can heat up and expel gas from the galaxy, shaping its evolution in dramatic ways.
So they can both create and destroy.
In a way, yes. They play a complex role in the evolution of galaxies. Sometimes their activity can trigger star formation, while other times it can quench it. It's a delicate balance.
It's amazing to think that these invisible objects can have such a profound impact on the galaxies they inhabit.
It is. And we're still learning so much about the intricate interplay between supermassive black holes and their host galaxies.
All of this makes me wonder about the long-term fate of galaxies. What will happen to them as the universe continues to age and expand?
That's a great question to ponder as we move to the next part of our discussion.
Okay, well, on that note, I think it's time to wrap up part 1 of our galactic exploration. Join us next time as we continue our journey, delving deeper into the mysteries and wonders of these cosmic masterpieces.
Welcome back.
Okay, so we left off talking about the future of galaxies
The part 2
as the universe continues to age and expand.
of our galactic adventure.
It's a bit mind-boggling.
Ready to delve deeper into the mysteries of the universe.
Absolutely.
Okay.
To think about such vast time scales.
It really is. But by thinking about these enormous stretches of time, we can start to grasp the grand cycles of the universe. Just like stars have life cycles, so do galaxies. They're born, they flourish, they evolve, and eventually their star-forming days wind down.
So, if a galaxy is no longer actively forming new stars, does it essentially become a cosmic graveyard?
Not quite a graveyard, but certainly a quieter place. Think of it this way. Even though new star formation might cease, the existing stars continue to shine. However, the galaxy's stellar population begins to shift over time.
What do you mean by shift?
Well, as massive stars reach the end of their lives, they explode as supernovae,
Right.
leaving behind remnants like neutron stars and black holes. Meanwhile, the smaller, less massive stars, which are much more numerous, keep burning steadily for billions, even trillions of years.
So a galaxy gradually becomes populated with more of these long-lived lower mass stars.
Precisely. And this change in the stellar population affects the galaxy's appearance in a very noticeable way.
How so? I'm picturing a galaxy full of tiny, faint stars.
It's not just about size, it's about color. Hot, massive stars emit bluer light, while cooler, less massive stars emit redder light. So as a galaxy ages and its population of massive stars dwindles, its overall color shifts from bluer to redder.
So that's why older galaxies often have that reddish hue in images.
Right.
It's like they've mellowed with age.
That's a great way to think about it. It's a telltale sign of their age and the evolution of their stellar populations.
It's fascinating how we can infer so much about a galaxy's history just by observing its color. It's like galactic archaeology.
It is. And as our telescopes become more powerful, we're able to peer even deeper into the universe and study galaxies at different stages of their evolution, piecing together the story of how they formed and changed over time.
Speaking of looking back in time, it makes me wonder about the very first galaxies that formed in the early universe. What were they like?
The first galaxies were true pioneers, blazing a trail through the darkness of the early universe. They were likely much smaller and less massive than the galaxies we see today, perhaps even 100 or 1,000 times smaller than our Milky Way.
So they were like the building blocks of the larger galaxies that came later.
Exactly. And they were probably quite chaotic, with lots of mergers and interactions happening as they jostled for position in the young universe.
Yeah, I can imagine the early universe must have been a pretty wild place. It's amazing that we can observe these early galaxies now, thanks to powerful telescopes, like the James Webb Space Telescope.
It is remarkable. The James Webb Telescope is like a time machine, allowing us to peer back billions of years and witness the formation of the first galaxies, capturing light that has been traveling across the universe for almost its entire history.
Wow. It's like having a front row seat to the universe's greatest show. And with each new observation, we gain a clearer picture of how galaxies formed and evolved.
Precisely. As we gather more data, we continue to unravel the mysteries of galaxy formation and evolution.
This makes me appreciate the vastness of the universe and the incredible processes that have shaped it over billions of years.
Me too. It's a humbling and awe-inspiring experience to study these cosmic wonders.
Before we wrap up this part of our discussion, I wanted to circle back to something we mentioned earlier. Supermassive black holes. They seem to play a significant role in the lives of galaxies.
They do. We now believe that nearly every large galaxy harbors a supermassive black hole at its center.
What exactly makes these black holes so supermassive?
Well, their name says it all.
Yeah.
They are incredibly massive, containing millions or even billions of times the mass of our sun.
Billions of times the mass of our sun. How do they get so big?
We think they grow over time by pulling in gas and stars from their surroundings.
Right.
It's a process called accretion, and it can be a very dramatic affair. And sometimes, during galactic collisions, supermassive black holes can even merge with each other, creating even more massive black holes.
So it's like a never-ending feast for these black holes, constantly consuming matter to grow larger and larger.
That's a good way to think about it.
Yeah.
They have a voracious appetite for matter.
But hold on, aren't black holes supposed to be invisible? How do we even know they're there if they don't emit light?
That's a great question. We can't see the black hole itself directly because its gravity is so strong that not even light can escape. However, we can detect their presence through their gravitational effects on their surroundings.
So it's like their gravity leaves a telltale signature that we can observe.
Exactly. Even though we can't see the black hole itself, we can observe how its gravity influences the motion of stars and gas in its vicinity. And the more massive the black hole, the stronger its gravitational pull and the more noticeable its effects.
It's amazing how we can infer the presence of these invisible objects just by observing their gravitational influence. It's like a cosmic detective story.
It is, and as our observational techniques improve, we are learning more about the fascinating relationship between supermassive black holes and their host galaxies.
So what role do these supermassive black holes play in the evolution of galaxies? Are they helpful or harmful?
It's a complex relationship, and we're still piecing together the details. But we know that these black holes can have a profound impact on their surroundings, both positive and negative.
For example?
Well, as matter falls into a black hole, it heats up and emits intense radiation.
Oh.
This radiation can create powerful outflows of energy,
Okay.
which can push gas out of the galaxy, influencing its ability to form new stars.
Wait, so black holes can actually blow away the very material the galaxies need to form new stars?
Yes. It's a bit counterintuitive, but that's exactly what can happen. These outflows can regulate star formation in galaxies, preventing them from growing too large or forming stars too quickly.
So in a way, supermassive black holes act as a kind of galactic thermostat, regulating the temperature and controlling the growth of their host galaxy.
That's a great analogy. They can help to maintain a balance in the galaxy's ecosystem.
It's incredible to think that these seemingly destructive objects can also play a vital role in shaping and regulating galaxies. It really highlights how interconnected the different components of a galaxy are.
It does. From the stars and gas to the central black hole, everything is connected in a complex and dynamic system.
Yeah.
And we are only beginning to understand all the intricate connections.
Well, we've covered a lot of ground in this part of our discussion, from the aging of galaxies to the power of supermassive black holes. But there's still so much more to explore. What do you say we take a short break and then come back for the final part of our deep dive?
Sounds like a plan. I'm eager to continue our exploration of these cosmic wonders.
Welcome back to the final part of our deep dive into galaxies.
The final part.
It feels like we've journeyed through billions of years of cosmic history,
Yes.
exploring everything from their birth in the early universe to the powerful influence of supermassive black holes.
Yeah.
We've covered a lot of ground, but just when you think you've grasped the scale of the universe,
Right.
there's always another layer to uncover.
You're right about that. And it brings to mind something I've been wondering about. We've talked extensively about how galaxies evolve over time, but what about the vast spaces between them? What's out there in those cosmic voids?
It's a great question. It's easy to get caught up in the dazzling beauty of galaxies and forget about the seemingly empty spaces that surround them. But, the truth is, those spaces, known as the intergalactic medium, aren't truly empty.
Right.
So what fills these cosmic voids?
They're primarily filled with gas, extremely thin and diffuse gas. but gas nonetheless. It's mainly hydrogen, the simplest and most abundant element in the
Is
universe.
this gas just left over from the Big Bang?
Some of it is, but other processes contribute to the intergalactic medium as well. For instance, as galaxies evolve, they can lose gas through galactic winds and supernova explosions. This gas can then escape into the intergalactic medium, enriching it with heavier elements.
So it's like galaxies are constantly breathing, exhaling, and inhaling gas as they evolve.
That's a great way to visualize it. The intergalactic medium is a dynamic environment with gas flowing between galaxies, enriching the cosmic soup and influencing the formation of new structures.
This makes me wonder, could this intergalactic gas ever clump together and form new galaxies?
It's certainly possible. We believe that some dwarf galaxies, smaller galaxies that often orbit larger ones, might have formed from gas clouds in the intergalactic medium.
So even though the universe is expanding and galaxies are moving farther apart, there's still potential for new galaxies to emerge from the seemingly empty spaces between them.
Exactly. The universe is full of surprises, and galaxy formation is a complex and ongoing process. Who knows what wonders are still waiting to be discovered in the vast expanse of the cosmos?
That's what makes studying the universe so exciting. There's always something new to learn, always another mystery to unravel. This deep dive into the world of galaxies has been incredible. We've explored their formation, their evolution, their diversity, and the powerful forces that shape them.
It's been a fascinating journey, hasn't it? From the first moments after the Big Bang to the intricate dance of galaxies across billions of years. It's a story that fills you with awe and wonder.
It certainly does. And I hope our listeners have enjoyed exploring these cosmic wonders with us today. And remember, the exploration doesn't end here. Keep looking up, keep asking questions, and keep marveling at the beauty and complexity of the universe.
Well said. There's always something new to discover, always another question to ask. The universe is an endless source of fascination and inspiration.
Absolutely. And for our listeners, don't forget to follow and subscribe to the podcast for more deep dives into fascinating topics. Until next time, keep exploring.